Hello, welcome. My name is Sembuli Moses. I'm an instructor here at Ntinda Vocational Training Institute. I'm going to display to you how the solar system works, which is off-grid. This solar system is the one which provides power that works for various domestic applications. We've got the solar panel. This solar panel transmits light energy into electric energy by the use of the photocells which are on the panel, which form the cells. In many of them, they form what we call a panel. Now, when the panel receives light, it transfers them into electricity. And that power which is being formulated or generated by the solar panel is connected through the charge controller. The work of the charge controller, it has got three functions. The first function is to control the charge from the panel so that it is not too much, it is not too low. The second one is to prevent a backflow. There's a backflow of power from the battery to the panel up, especially in the night when there's no radiation. And the third one is for a low voltage cutoff. In case there's no radiation and the battery is being overdrained, this charge controller, it does the cutoff. Then after that, we have the battery. The battery is that which stores the charge from the panel. Then from there, we go to the inverter. The inverter inverts the direct current voltage from the battery to AC, that is alternating current for the usual domestic applications, which is a standard voltage between 220 volts to 250 volts. Then from the inverter, we go to the main distribution board. Now this main distribution board, it has got a number of outgoing final sub-circuits to the sockets, to the lights, and to other applications that as per may be the need. Then these are the accessories like the junction boxes, the conductors, and the bulbs, and the other equipment which we use in the wiring. So now, we are going to put the solar panel and make for you a demo how is it installed. So here we install it at an angle of inclination. So it's being clamped so that it does not fall out. Even here it's being clamped so that it does not fall out. The clamps, these are the conductors from the panel. The conductors from the panel. Now, these conductors are being clipped. And have to be a little aligned. So we can add one here. Now when the clamping is done, we bring the power to the charge controller. It has to be controlled. The power has to be controlled through the charge controller. So in connecting, usually we start with the negative, this negative. And this is the power from the panel. It is controlled. Then you connect the negative, the positive. Now we connect, it gives giving us 23.2 2 volts. Then what we do now, what is next is to connect to the battery. Again, we start with the negative. Don't start with the positive. Now, to avoid short circuit, we don't connect both the positive and the negative. We first take the negative to the battery. This is now the negative terminal. We'll connect to the negative terminal. To make sure an electrical connection should be always electrically continuous and mechanically sound. It should not pull out under normal circumstances, under normal strains. So we make sure it is firm, very firm. Now from there we'll connect the the positive. In DC we don't have live or neutral, but we have positive and negative. So now you connect the positive terminal. Mpire screw. Usually what we do for easy monitoring, we put so it's okay.
It's supposed to be straight.
Come on, look at it, straight. Go on. Now these are the tools being used. Then from there, once our battery is done, we are done with the battery, we are with the charge controller and the battery. Then we get our inverter. Now before we connect the inverter, because now this will be a live circuit, we have to first put the MCB. What does MCB mean? It means miniature circuit breaker board. Now, this board here is where we connect the incoming supply from our inverter. Then from there, we connect the outgoing final sub-circuits. That's now the lighting and the sockets. Just a MK box. This. Screw ngono bulungi zinkwata bukwasi kubanga ekizibu kyemanyi Nenda kafuli. Take it out, too far. Take it out, too far. We are missing a screw. An angle, then it comes in. Clamp. It is not a plug. Sako cover. Sako cover. All right, now this is the finished work of our solar system. We see right from the power source, from the sun to the solar panel up to the lighting point. Now, let us see. We have the solar panel which has given us the power. Now this power comes to the charge controller. It comes all the way to the charge controller and giving us the voltage which we want. Then from the charge controller, it comes to the battery. The battery uses our power bank, which keeps our charges. Then from the battery, it gives us the DC voltage, which is connected to the inverter. The work of the inverter is to convert DC to AC, that is direct current, to alternating current, which is the end user voltages to most of our houses. Now, from the inverter, we come straight to our main distribution. This is our distribution, which distributes to the outgoing final sub-circuits. Now, this is our inverter. When we connect it, it gives us the end user voltage between 220 volts to 250 volts. Then we switch on our main switch in here and it gives us the power, and then we can be able to light our installation. Not only the lighting the installation, but also powering the installation for the electronics, for radio, for phone charging, for television, for blender, for using the kitchen. So basically, this is our solar power system, which is being connected. And we can do this work between 30 to 40 minutes, and we are done with it.